For this problem, we have the following circuit diagram. We have a 25 kilo ohm resistor up top. We have a 100 kilo ohm resistor next to it right here. And then we have a 0.4 microfarad capacitor. And then we have our Vi and then our V naught. We need to find the S domain transfer function. H of S is equal to our V naught over our Vi. So we're going to need to come up with an equation for this. Well, what we can do is compare this to these. And these notes, these three down here, are from the Engineering 17 notes, Introduction to Circuit Analysis. There's a playlist somewhere on the channel, but they're going to be in section 3.3 and 3.4, labeled Voltage Divider, Current Divider. This is the voltage divider. And so we can compare it to this voltage divider format right here. It's going to look something like this, but that's okay because this voltage is in parallel with this resistor. So it's basically the voltage across here. And we're going to look at that. Before we look at that though, we are going to need to combine these two impedances because they are in parallel. We know that this capacitor, we can write it as Z of C is equal to 1 over our S of C, or S times C, sorry. And we're not going to plug in this C yet, just to keep things simple. So when we write this, do it in red for the impedance, we are going to have 1 over our first impedance, which is 100K, plus 1 over our next impedance, which is 1 over SC, and this is raised to the negative first power. So we can deal with our 1 over 1 SC and write it as plus SC negative 1 like this. And then we can rewrite this again. We are going to have 1 plus SC 100K divided by 100K. And then this is being raised to the negative first power still. So all we need to do is flip this. We are going to have 100K divided by 1 plus 100K S times C. And so this is going to be the impedance over these two impedances. And now our equation is going to look something like this, or our circuit diagram is going to look something like this. We still have our Vi here, and then inside of here we are going to have this resistor, 25 kilo ohms, and now we are going to have this total resistor right here, where we have 100K over our 1 plus 100K S times C. And then we have a node here, and then also a node is after every single circuit element. So it's going to be like this. And actually, we don't need a capacitor here because we've combined it with this resistor. So for here, we'll just have our plus minus V naught. Now, it's very similar to this. We see that we have our source voltage, our Vs right here, and we can say that our V1 is like that. We have this resistor right here, and we have this resistor right here. And then, well, we have this resistor in parallel with this voltage. We have this resistor in parallel with this voltage. So we can write this out using this equation. We are going to have this V2 is equivalent to this V naught that we have. So we are going to have V naught is equal to our V of S, and our V source is right here, just like this is right here. So this is equal to our V1 times our R2, and our R2 is going to be this. So we have our V naught is equal to V1, then you have the R2, which is 100K divided by 1 plus 100K SC, and this is all over our R1 plus our R2. Our R1 is this 25 kilo ohms, and then we've plugged in our R2, so we're going to have 25K plus 100K divided by 1 plus 100K SC. Now what we can do is we can move this V1 over to this side, and if we do that, we're going to see that's exactly what this equation is asking us to do. So we can say that our H is equal to a V naught over V1, and this is equal to, well, now we're going to look at this. To simplify this, we can multiply the top and bottom by this 1 plus 100 KSC, and that will get rid of the denominators. So we are going to have this equal to 100k, and this is being divided by, we have this 25k, and then we're going to have a 1 plus 100k SC plus 100k. So after we write this, we can just say that our h is equal to, we have our 100k still, and then underneath this, we're going to distribute this 25k in. So we are going to have 25k plus a 2500, or we can write this as 2.5, or no, we can just do 2500k times k s times c, and then we're going to have a plus 100k. Now in here, we can see that our k's can be canceled out. We have a k in all of these. Next, what we can do is we can add the like terms. So we're going to have 100 divided by, we have this 100 plus this 25, and that's going to give us 125 plus this 2500k times s, and we have this c in here. So this c is this c right here, and our c is equal to 0.4 times times 10 to the negative 6. So if we plug this in here, we're going to have a 0.4 times 10 to the negative 6. And then we can plug all of this into a calculator, 2500 times 10 to the cube, because that's what k is, times 0.4 times 10 to the negative 6. And this is just going to give us 1. So with this s, we're just going to have s here. That means our answer is just going to be 100 divided by, we have our s plus 125, and that is the answer for this problem.